All right, so welcome back. Today's July 9th, week 11. Some things off the calendar to note right away. Our last day of actual instruction is going to be this day, the 26th. And then on the 27th, we're going to meet here just to make sure everyone's here. And we're going to go trek off to A-Flight. So A-Flight is a software consultancy here in Chicago. One of our Bravo Platoon graduates just got a job there after what has that been? I think he got an offer last May or June or something like that. He's got a year-long apprenticeship just to make sure that he's up to snuff in terms of all the technologies. He's learned like 5 or 6 different languages and 4 different frameworks since then. And then now he just got his full-time offer. But if you want to like learn more about that, go to aflight.com. They're one of our, they always support us. They've hired Scott. Nicole Carpenter is, one of their software craftsmen there. And then they just write really great software. So what they do is companies will have a shortage of labor, right? And it takes a long time to find certain people to fill those particular roles. So what they'll do is they'll hire a company like A-Flight, and they'll say like, hey, like there's we need to build this project in 6 months. And they're like, okay, no problem. We'll give you 4 of our developers at $150 an hour. So per day, they'll spend, 600 times 8, $5,000. $5,000. Thing's kind of comical, but it's probably $5,000, and then they'll go on site, and then they'll figure out what they need to build, and they'll build it for that particular company. Yeah, it's all local. So if you've ever done consulting work where you had to travel Monday through Thursday, that doesn't really apply here. This is just a company that's all local. So when I was working at Groupon, they had an entire team that was all A-Flight. I'm talking 10 people. So that's $150 an hour times 10 times 8 times 40 because they were there for the entire week. So we will be working out of there for our final project. So they have enough senior developers and product managers and project managers just to get your idea off the ground to get you started on for those couple weeks. We'll be there on the 27th, all of the following week after that, and then the Monday after that. So it'll be, I believe, 7 days? 7 days at an actual professional software company. They have a conference room for you to work out of. They might not have monitors, but they are only 3 blocks away, so we might just take all of our stuff over there and walk over. But it's kind of fun just to kind of work out of an actual place that you can see the best software practice. They'll do stand up every single morning. You'll probably see some pair programming. You'll probably see some test-driven development, all the great things that make software great. So we're going to be going on the 3rd, going to A-Flight. We're going to meet here at 9 a.m., then we'll walk over, and then we'll be back on the 6th. Nope, that's not right. We will be there on the 27th and coming back on the 6th. There are a few other things happening between now and then. There's quite a bit that we still need to learn and still need to teach between now and that particular bit of time. Let's just go through the calendar to get us started. Today, I'm going to teach a little bit of React stuff, things that you're going to need in order to get to React tomorrow. We're going to do that from today until probably 11 or so. Then at 2 p.m., I met some guy in a coffee shop who's like, yeah, I'm the director of software at a company called TableXI, which is another one of the, another software consulting company here in Chicago. He's going to be coming in to talk about how to make your Rails app production ready. And evidently, he gave this talk before. So he'll be coming in this afternoon at 2 p.m. Tomorrow morning, we're going to do individual capstone presentations. We're not going to do it today because I want everyone to be available. And a few people were like, hey, something came up, I'll be in tomorrow. So we'll do that tomorrow morning at 9 a.m. On Wednesday, we're going to have a person coming in from application security. If you want to get into the cybersecurity part of the industry, he's going to be coming in at around 2 p.m. for that. Thursday, I'm getting observed by Alicia. Alicia works for us as a grant writer, just to make sure we're in compliance with XYZ thing. You remember she came in to judge Josh, and now she has to come and judge me. On Thursday, also starting at 5 p.m., we're going to have a Vets in Tech meetup, and that's just our Code Platoon's open arms to the community. So you'll see a bunch of people either coming in here. We might go to the 5th floor. It's just going to be a socialization hour. So they'll probably talk to you. Hey, how was your time? I know at least 1 or 2 of the people coming are going to be actually in the next course. So if you want to talk to them about that. I think that's all for this week. We have a couple more Beyond Techs for next week and the week after. One is how to deal with job offers and salary negotiations. And then the one after that is going to be job searching after Code Platoon if you don't get an internship. 3 companies are coming to present. One is Granger. They are not guaranteed to hire because they hired one of our graduates from the last cohort, but he got called up to active duty for a year. So he'll be back next year, and he's got his spot waiting for him. But they're like, we still need to fill that spot that we saved. So they're going to be coming on Friday. They are going to interview with no guarantee to hire. So Granger is that large, like, they sell waste baskets, so like this waste basket and stuff like that, and like commercial buildings. So they sell like they're the commercial Amazon, the commercial building Amazon. Change Healthcare will be coming on Monday the 23rd. They are signed on to take one with a guarantee to hire, and then same thing with Catalytic. It's another, I think it's a healthcare company. I'm not sure. But yeah, before they come in, make sure you research them, make sure you have good questions and stuff like that. First impressions do matter. If you're not from Chicago, there's a event going out about 4 blocks east from us called Taste of Chicago. It's going to start this Wednesday and then go until Sunday. It's an outdoor like music, food festival, like where a bunch of vendors come in and sell overpriced food. But it's a lot of fun. I've gone a handful of times. It's just good if you've not been to Chicago and you're here in the summer, you might as well go and take a look around. You don't have to buy anything because it's like a burger is like $15 kind of. It's like a catered, like gross old burger is $15, but it's just kind of fun to go and walk around. With that, we will get started on today's stuff. Any questions on anything related to the calendar, things to look forward to, questions, period? No? All right, let's do it. All right, so we're going to teach 2 frameworks. The first one we taught was Ruby on Rails, which we spent like a good 3 weeks on, and then so that's more of like a back-end full stack framework. And we're going to be talking about React.js. React is a framework given out by Facebook, and that's a front-end framework. So generally speaking, when we talk about, you can generally use for your final project. Oh, real quick for the final project. Think through ideas that you would want to build. Remember, this is your own portfolio piece. This is what you're going to be showing off to different employers when you're saying like, hey, hire me. I have qualifications and things like that. It's going to be group projects. Josh and I are still working through the teams. We're thinking either 2 teams of 4, probably 2 teams of 4, maybe a team of 5 and a team of 3, maybe a team of 2, 2, 2, 2, 2, but most likely 4 and 4, including remote. Yeah. We've never pulled this off with remote, so remote, if you're Jackie and John, like, I'm not sure what's going to happen with this or how it's going to work out. We're going to try our very best to make it work with everybody. So back onto React, we're going to be working on this for the next 3 weeks. Just as much time as we spend on Rails, we're going to be spending on React. So this first little bit, for the first 20 or 30 minutes, and then we'll take a break, is just more of a history before we get into the actual like nitty-gritty portion of it. So this is more of like a history lesson that I thought was kind of useful, at least. So you got to rewind back 8 years to 2010. Around 2010, it was like the iPhone 3, I don't know, iPhone 4 or something like that. And mobile devices started to become very, very popular. As a result, people started building out front-end frameworks like Angular and Backbone. And these particular frameworks helped developers create UIs, user interfaces, without worrying about the code that connected to the UIs, including getting how to get models up to views, connecting routes to controllers, writing a lot of HTML and CSS. Like those front-end frameworks took away a lot of that code. They just kind of hid it for you, so you just had to learn the framework code rather than actual writing HTML, CSS, and all that other stuff. So React.js is backed by Facebook. It's an open source project by Facebook, and it's the latest and greatest front-end framework. There was a period of time around 2014 when I first started developing where there was literally a website called Number of Days Since a JavaScript Framework Was Released. And that summer, I think the maximum number of days was like 56. So every 56 days or sooner, like that, there was a new JavaScript framework being come out, and everyone was like, Angular is the next best thing. No, Backbone's the next best thing. No, Ember is the next best thing. All 3 of those are still around today, but React is, because it's backed by Facebook, is the latest and greatest. Like they're going to stick with this for a longer period of time. There's companies like Oracle that back Java, Google backs Go and Python, and most financial companies still use C# and C++. And generally what you can think of is when a large company backs a language or a framework, it'll be around for a long period of time. So the React's not going anywhere. It'll go away at one point in the future, probably 3 years from now, 3-4 years from now, something else will take its place. But for right now, React is the latest and greatest. So you may be wondering, it's like, if Rails does everything for you, why even learn front-end web development? So basically, over the past few years, we've seen a huge shift from the responsibility of most of the code being needed from back-end to front-end. So let's talk through the MVC model. What does MVC stand for?
Models, views, controllers.
Okay, if someone had, so it's a very popular interview question. MVC stands for Model View Controller. How does that work? And that's an open question for anyone.
The model, the model points to the controller points to the view.
The model points to the controller points to the view. I agree with half that statement. The controller does point to a view. I do agree with that. But the model connects with what? Yep. So generally speaking, I go onto a website, I press a button. That button or that link is a controller action. The controller action is the brains behind the entire application. It'll talk with the view and it'll talk with the model. The model, all it does is just go back and forth between the database. The view is just like whatever shows up on the page. But the main brains of it, the controller, it controls all of the logic behind all of your code. The problem is with more and more users, there's more and more load on your servers. So if you imagine if the entire world had apps written in the MVC model, it's very, very back-end heavy, meaning that the more users, there's more and more users being exposed to the internet every single day, right? Third world countries are getting mobile devices and computers and things like that, and there's more and more people using computers. There's not enough money or physical space in the world to keep up with the growing population, how much stress is put on the infrastructure of the web. Imagine if you had one central point of failure, which is like, 50 million people are going to load up this website and hit it all at one time. And then they're going to press a button and it's going to do a whole bunch of database calculations. It's going to exponentially get larger and larger over time. But what they decided to do is they're like, how do we distribute the load from the servers onto you? And what they found is that every single person who's basically got one of these, or one of the computers that you have a very powerful modern browser on there. You got a Google Chrome, you got a Safari or something like that. Those types of browsers are able to handle most of the stress for you. So it's basically, I make one request over to the database and it sends a whole bunch of crap right back to me. That whole bunch of crap is stored on Google Chrome and I don't need to make subsequent requests to the database unless I need to. That's the whole idea behind it. Front-end browsers can take care of routing, displaying data, like displaying pages, making API requests in the back-end. It's not all back-end heavy now. So the idea is take all the load off the servers and put it directly onto the user itself. Remember that in front-end development, there's everything at the end of the day is still HTML, CSS, and JavaScript. I'm going to share a document that's going to help you note all the differences between React and Rails. But at the end of the day, whether you're using Angular, you're using React, you're using Backbone or Ember, it doesn't really matter. In the end, it's all HTML, CSS, and JavaScript. Those things are never going to go away. So we're going to talk about browser history today, the evolution of JavaScript, which is also known as ECMAScript. So the formal name for JavaScript is ECMAScript. We're going to be talking about NPM, which is Ruby gems for Node. We're going to talk about static analyzers, so Rubocop or it's basically Rubocop for JavaScript. Talk about unit testing, ESX, and create React app. So first off, a brief story in history of front-end tech. So I think the best book I've seen so far is a book called Web Design for Babies. Very, very simple to understand and honestly explains things better than I can. So first things first, again, like I said, all front-end code comes down to HTML, CSS, and JavaScript. First things first, HTML. I'm the structure of a web page. My job is to get things started right. My team of helpers and I build a solid foundation by turning text documents into web pages. We're like the beams of a house. A web browser reads my file and displays it as a web page. So the structure of your page, how big everything is, how like just the bare bones of it, just like the like what the houses are structured to look like. Then you got CSS, the CSS stylish person. My style rules tell the HTML elements how they are to be displayed. Every single rule has three parts: a selector, property, and value. So you got a selector, a property and value, a property and value. So you have the bare bones of it, and then you have throw some style on top of it. And then finally, you got JavaScript. I'm the function of a web page. I help web pages do cool things by making changes to HTML elements. I react to events, like when you click your mouse or point to a certain web element. Like when you go onto a website and you click a link, it was blue, and then when you go back, it's purple. Those are types of things that JavaScript will keep track for you. These things, mostly JavaScript, when we start dealing with, is going to handle things like button clicks or keyword events. Like I was telling you, I had to write some JavaScript once for a company that will remain unnamed, which was basically the moment you started typing your email address on a form, we had it. You know, like I created a JavaScript event. This is listening. Whenever there's a keyboard, click onto this thing, and then there's any sort of movement on there, start recording it, and then when they click out of it, send it back to me. Yep, that's what we did. It's very, very unethical. Let's go back to 1993. So in 1993, the internet already existed, and multiple browsers already existed as well. There's a man named Tim Berners-Lee. I think he still lives in Chicago, if not Silicon Valley. He was the person who wrote the HTTP protocol. Remember, GET request, POST request. So he wrote that protocol back in 1993. And he had his own browser, which was called the World Wide Web. Later, it was built into OS X, like Mac's operating system, and then later renamed Nexus. This is the original internet. We've come a long way since then. This is another text-based browser called Lynx. This looks more or less like what I grew up with in terms of the like the library and renting out books from the library. But this is another web browser, if you can imagine how far we've come in 25 years. But the most popular browser was one called NCSA Mosaic. It was built at UIUC, which is a huge like research computer science place. Like they do hire. Google hires a lot out of UIUC, which is just 3 hours south of us, I think. At the NCSA, which is the National Center for Supercomputing Applications. This was like the most popular browser by far. So in 1993, because the internet was created, we needed to create the first HTML spec for basically like, how do I write HTML? And it was written by this guy named Tim Berners-Lee. He's a very cynical person. All these quotes are directly from him, so you can kind of see just how cynical of a guy he is. And he was thinking, as the number of web browsers is beginning to grow, it's important to create official HTML standards, right? It's like, imagine if everyone was starting to get cars and driving, or imagine we had flying vehicles for once. Or a more realistic example is the drones. When drones first came out, there was no regulation, and then it became mass commercially available, so they had to create specific rules around drones. Same thing here. A lot of people are starting to use the web. It looks something like this in the background. And as more people are using it, you need to come up with more rules. So in 1993, you create the HTML 1.0 spec. And then 1994, a year later, he created the W3C. So the same one as the W3C schools that you use online for all of those resources. It's a web standards committee that's responsible for maintaining and iterating on HTML standards. So they are kind of like the central hub, the brains, the organization that manages all official HTML and all official CSS and things like that. The idea is, don't get hit by a bus. If he's the one that writes all of the milestones and all of the specs and he gets hit by a bus, then everyone's screwed. But if an organization owns all of that kind of stuff, then it's much safer. At the NCSA, the creator of Mosaic, one of the creators was this guy. His name is Mark Anderson. And he left in 1995, where he decided to start a new company called the Mosaic Communications Company, where he aimed to create the Mosaic Killer, a revolutionary web browser. So he created the killer of Mosaic, which is this particular browser. You can actually go here, home.mcom.com, and you can kind of see like this is like when we were kids. This is what the internet looked like. The main thing between Mosaic, this thing here, and the Mosaic Killer the thing that Mark Anderson decided to write is that he was able to do navigation within images. And it seems so simple today that when you click an image, that like it'll either come up bigger or it'll lead you to another website or something like that. But this was revolutionary. Like everything up to this point looked like this. It was just one giant picture, and then you could embed HTML links. But this was a really cool thing. You could actually click on entire pictures, and it was able to do things. So this was one of the links on the page. And do people remember Netscape way back when? That was created by Mark Anderson, and he created a commercial web browser that was paid. And he said, like, because it's paid, this web browser is going to defeat all other browsers. So we're talking about like really quick iterations in the early 90s, so there was a lot of money to be made. They knew that this was going to be a big thing, but all these guys are decamillionaires now. So 94, so 93, the web was born. 94, the W3C was formed. 95, there was Netscape Navigator. So it's like very, very quick timeline that we've got here. The big thing to note at what Netscape's like willing to offer is this secure communications. And up to this point, the HTTP protocol was created, but it wasn't secure. Because Netscape was offering secure communications, you could have e-commerce. You could enter your credit card information on the web without having to worry about it being stolen. So it's fast, it's reliable, it's consistent, and it's secure. This is the only browser at this particular point that has secure communications. And you can have it for the low price of $49.99. Like, it seems so laughable now because all of our browsers are free and visiting the web is free until net neutrality kicks in. But people were happy to pay this $50 price tag in the 1990s, which was probably worth, what, $200 bucks, $250 today, because they were able to do online shopping and not have to worry about all of their stuff being stolen. And soon after, they came out with Netscape Navigator #2. Around this point, when the web started becoming more popular and you had a lot of browsers entering the market, Mark Anderson said that as the internet's growing, we're going to need to create a browser-based programming language. So can anyone guess what the first browser-based programming language was?
JavaScript.
It's not JavaScript. Good guess, though. So it's actually just Java, created by Sun, and they created an alliance together. And the first web-based language was actually Java. So Netscape and Sun joined forces to make this happen. And Sun obviously said, we want this to be the only browser-based programming language, mostly for job security, but to make sure that their company stayed alive forever. But however, they quickly realized that Java was way too hard for amateurs and for beginner programmers. They needed a language like Visual Basic, something simple and casual that programmers could quickly put up and could quickly be put into HTML like this. So Mark Anderson said, like, as they were creating JavaScript, we aim to create a glue language for web designers and part-time programmers who are building web content from components, blah, blah, blah. He basically said, we needed like a glue language, something behind the front end and the back end. And so like at this particular point, this is an example of applet code. And this is how I would load Java into HTML at this particular point. The person tasked to create this browser-based language his name was Brendan Eich. He was part of the Netscape team. And he created JavaScript in 10 days. Like both the language and the entire engine that powers it, like in 10 days. So the amount of time it's going to take us to learn React is the amount of time that he took to write the entire language. He called it Mocha, and Mocha script. So there was a lot of coffee references back in the day, if you remember Dilbert cartoons. And then finally settled on JavaScript. But it was really, really buggy. He was the only person working on it, and he finished it in 10 days. You can kind of see his quote, I perpetrated JavaScript in 95, and I've been making up for it ever since. And as a result, in the same year that Netscape Navigator was created, they released version 2.0, which supported Java and JavaScript. Remember, these two aren't the same thing. And then soon after that, webmasters, the original web developers of the 1990s, said that the original HTML specs are not robust enough and that we need to move on and continuously update it. And then within a year, HTML 2.0, the specs came out. If you remember the early 90s, like right now, like the largest company in the world is Apple, if I'm not mistaken. But what was the largest company in the 90s, would you say?
Microsoft.
Microsoft. So I haven't mentioned Microsoft at all, despite being the largest operating system at the time. So if you remember Windows 95, that was like, at the time, it was like a beautiful system. You know, I still remember the minute and a half startup button, you know, like, and the screen coming on, it doesn't power on right away. It had to like warm up and then like it slowly get onto the page. But basically what Microsoft did is 1995 was a big year. They released Windows 95 and it included their 1.0 of their browser, Internet Explorer. And now I know that Internet Explorer is something that you basically use to download Google Chrome. But back in the day, like this was awesome. This was the thing. You can kind of see two parallels. Internet Explorer is always kind of catching up to Netscape Navigator. And Internet Explorer 1.0 and 2.0 is basically a rebranded version of the Mosaic Killer. It originally came free with an enhanced version of 95, but then came pre-installed on all versions of Windows. And you might be saying, if Internet Explorer is the same thing as Netscape Navigator, why doesn't Netscape Navigator just sue the crap out of Internet Explorer? It's because Netscape Navigator is charging $50 and Internet Explorer is free. Because it's free, you can't sue. You can't charge royalties, and you can't sue for royalties because it's free. So as a result of that, you had Netscape Navigator that's paid, Internet Explorer that's free. Netscape Navigator is always better than Internet Explorer. You can kind of see one is always catching up to the other one. But because it's free, Netscape's market share began to drop, and you began the browser wars of Internet Explorer versus Netscape. And this battle continues today. It's Mozilla Firefox versus Google Chrome. Something else will come onto the market eventually, which will challenge Google Chrome and continue on and on. During this period of time, CSS also came up to this point, was also created. And up to this point, people had not actually been able to put the code into HTML itself. So they were able to create style sheets so they can reuse styles over and over again. Next year, Internet Explorer 3.0 comes out, and shortly after, Netscape comes out, and Netscape had about 90% of the market share at this particular point. But Internet Explorer had the same features, and it was free, and they had CSS support, and they allowed for other languages like C++ to be put into the web page, not just Java. Internet Explorer also wanted to create new tags and not wait for the W3C. They were always cutting edge. They were always kind of pushing the boundaries. And that's why you'd see things on web pages like this. Best viewed with Internet Explorer, or use Netscape 3.0 now. These logos generally recognize the divergence between standards supported by the browsers, which signified which browser was used for testing pages. And basically what happened was, you know that Netscape Navigator is no more, and you know that Internet Explorer is still around, RIP Netscape. And the main reason was that Netscape had always pushed the boundaries at first, but they weren't willing to change with the market. It was $50. They weren't listening to the webmasters at the time. They weren't able to move quite as quickly as Microsoft. And that's why Microsoft took over and Netscape is no more. So you're seeing kind of the same thing now where Microsoft's not able to change as quickly, and then Google ate their lunch. Now Google is starting to slow down. The Microsoft is starting to expand a little bit more by buying out GitHub and trying to become more of like a modern day thing. So it's this smaller companies always move faster than larger companies. Everyone knows that. But like at a certain point, like there's all this market pressure, and then you're going to have to start being more, I guess, purposeful with your decisions. And then that's when you start losing market share. Then it kind of goes round and round and round. Well, it's not forgotten. Netscape, like it's gone, but it's not forgotten. Netscape gave birth to a lot of things like secure communications using HTTPS. It created JavaScript. It created Java plugins. It created C++ plugins. Like there's a lot of good things that Netscape had. So we don't know what's going to happen with the future of our browsers and our operating systems. So that's kind of to be continued. Should we take a break or should we keep going? You guys good? Keep going. All right. So we're going to move on to JavaScript. So that's a little bit about informal background of like how we got to this particular point. So we're going to talk about JavaScript and all the things we need to know and be reminded of before we get into actual React code tomorrow. So today we're going to talk about JavaScript and all ESLint and Next and all that type of stuff. So we're talking about JavaScript. JavaScript, the formal definition is a single-threaded, non-blocking, asynchronous concurrent language, which means absolutely nothing to anyone. Here's a little bit more of what it actually is. JavaScript is not arguably the most popular programming language. It is the most popular programming language. Every single, like, you can choose whatever you want to do on the back end. So there's people who are like, I swear by Java, I swear by C# and C++, I swear by Rails or in Ruby. Doesn't matter. Whenever you do anything with the front end, there's JavaScript on it. Every single browser, every single phone, every single computer, everything more or less has JavaScript. It is the most popular programming language in the world. 23 years old. It is code that runs within a system browser runtime and a system runtime. It's the system thing is a little bit more recent with Node. Its standards are maintained by TC39, which is a group within ECMA International, which is within W3C schools. For $3,000 a year, you can also join it and see all of the things that they're proposing and vote on it and things of that nature. So it's always an evolving, breathing thing. There are 4 major JavaScript engines that power pretty much every single major browser. So Google has something called V8, Apple has something called WebKit, Microsoft has Chakra, and Mozilla has SpiderMonkey. So generally speaking, you write the JavaScript code. These are the engines that are going to power it to show up on your particular browser. That's why JavaScript works on certain things and not on other things. Like, how many times have you seen something work in Google Chrome that doesn't work in Internet Explorer? It's because it's probably because the engine's a little behind. So let's break down this gross thing right here. Single-threaded, non-blocking, asynchronous concurrent language. So single-threaded, I'm going to mute you, John. Oh, thanks, John. So single-threaded means that it's one thing happens at one time before you go through anything else. So I've got a whole bunch of code right over here. Var a number equals 42 and all of these things. And I'm going to console log 1, 2, 3, 4, 5. Single-threaded means that it's going to do one thing at one time. So line 1's going to finish, then line 2, then line 3, then line 4, 5, and 6, and then only after that are these particular lines going to operate. So it's single-threaded. One thing is going to happen at one particular bit of time. So we have a heap, and we have a call stack. Heaps store variables. It's like basically your memory management. When you define a variable, it's stored inside of memory inside of your heap. Call stacks call functions. When one finishes, it gets removed from the call stack and then moves on to the next step. You can think of it kind of like as a giant layer of pancakes. So the last thing that's like, if you imagine building a stack of pancakes, you have 1, 2, 3, 4, 5. The last one in is the first one out. That's what's going on over here. Inside of JavaScript, JavaScript gave us the ability to do many things with web APIs. An example is the DOM. It gives JavaScript the ability to modify HTML code live on the page. There's other examples here in this link, but some of them include alerts. So whenever you fill out something and then there's an alert box that shows up, like it's a pop-up. It's a pop-up that shows up that'll basically say, it'll modify the web for you. So that's stuff that JavaScript handles. It's not built into HTML, but it's JavaScript that handles that. And Web API, another one that we're going to be using in a week and a half, is HTML fetch requests. It's JavaScript making API calls directly from your browser so that it's not Rails making the request, but it's actually JavaScript. So let's take a look at this particular bit of code. Synchronous API calls. So we're going back to a synchronous thing is something that executes immediately. If I were to run this particular bit of code, what do you think would happen? Any thoughts? Yeah, it's basically saying JavaScript is going to grab the entire Windows document, so the entire DOM. It's going to change the body's HTML to just hello world. So what you'll just see on the screen is just hello world. I'm not going to copy and paste it. You can copy and paste it on your own. But basically what it's going to do is just take that body of HTML and just replace the whole thing with hello world. And the code that we've written so far in Rails is mostly synchronous code. It executes immediately. The exception of this is jobs, which we talked about a couple weeks back. Think of synchronous code as I go to the dry cleaner in the morning, I drop off my clothes, and I wait. That is a synchronous job. You do one thing and it executes immediately, but I'm going to have to wait for it the whole time. On the other hand, you have asynchronous API calls, which is basically I'm going to execute immediately and respond at some particular point. So I go to the dry cleaner. If it's a synchronous call, I go to the dry cleaner, I drop off my clothes, and I wait. No one's going to do that. You're going to go in the morning before work. You're going to get there, drop off your clothes. They're going to give you a ticket. So it executes immediately. They give you some sort of acknowledgement, something happened, and it'll be done at some period in the future when I have time. I can just guarantee that it'll be done by 5 p.m. today. So the idea is I go there, I drop it off, I get a response right away, and then it'll be done sometime in the future. You don't call the dry cleaner halfway through the day, hey, did you get my stuff done? You just trust that it's going to be done by this particular bit of time. So you're provided a callback function that gets called whenever the call completes. So basically, if I have this window set timeout, I'm going to console log hello world after 1,000 milliseconds, which is 1 second. So it's like, I'm going to acknowledge that this happened right away, and then after 1,000 milliseconds, then it will console log hello world out to the screen. It's kind of like jQuery's Ajax from week 5. So it's a little bit about the single-threaded asynchronous, all that kind of stuff. It's just JavaScript. So a new thing that we're going to be bringing in is something called NPM. NPM is the exact same thing as Ruby gems. It brings in libraries into your code. Remember, a library is thousands of lines of code. Somebody else wrote it, making your life a little bit easier. When we go to npm.js, it's a lot nicer than Ruby gems, but all it includes, it's a company that takes all of the gems, all the libraries in the world, and just packages it and like registers it under here. You can kind of think of it as a phone book. Like every single person in here has a phone number. The phone number is listed somewhere. The listed somewhere, whatever does that, is NPM for libraries. And there's no shortage of libraries. Let me just look for where there's one called HTTP server that we're going to be using today, which is going to create a server out of, somebody wrote the code for you to create a command line HTTP server with just one library, and you just write run, and then it does it for you. You know, it's been downloaded 121,000 times this particular week. The last published was 6 months ago. You can kind of see the repository here on GitHub. And then there's all of this stuff of like, how do we actually use this particular bit of code? Anything that you could possibly think that you would need is probably already written with Node. No, oops. So yeah, Node package manager, same thing as Ruby gems. It's in Oakland. Yeah, basically all of that. Remember when we did gem install Rails and then Ruby gems installed the entire Rails library? Same thing here. We're going to do npm install React. npm stores the React library amongst other libraries as well. You're going to see a lot of everything is the same. It's called Ruby gems. This one's called npm. Gem install Rails, npm install React. Same thing here. If you go into Python like I'm doing now, it's pip install Flask. You know, it's all the same thing. npm comes prepackaged with Node. Node can be directly installed or can be managed using the Node version manager. We installed it on day 1, so it should be running on your computers just fine right now. So whenever you want to bring in Node, run this particular command up here, npm init. And this is basically going to prompt you for all the things you're going to need for that project, and it's going to create what's called a package.json file, this thing right over here. It's an area for you to list out all the dependencies and all the configuration that you're going to need for your Node application. And I'll run through this after I finish this, and we'll take a break. If you look inside of the npm, if you look inside package.json, you're going to see a little something like this. It has most of the stuff that we entered in a little bit earlier. So when you run npm init, it's going to ask you for the name, version, description, all this type of stuff. But if you look inside of it, it's just going to look like a giant JSON object. And it is, because it's a .json file. When you want to run dependencies and save it into your computer, this is the command that you're going to run. So if I wanted to run npm install react -- save, this -- save is actually going to save it into my package.json file. If you'll notice that when I install react.js, I also get all these extra dependent libraries. In order to run React.js, I need all these extra things. Similarly, when you run Rails, you need a lot more other libraries as well. Another thing that we're going to need to know is something called ESLint. It's a static tool to basically check your code and make sure that it looks good, it's up to standards. It's more or less like Ruby's Rubocop, but it's far more robust than that. So ESLint helps you write better code, helps your team write consistent code. So you can kind of imagine if you had 12 developers, all with differing skill levels and different backgrounds, by having ESLint, you'll make sure that everything across the board is standard. And it reduces your bugs. When you run ESLint against a particular file, like ESLint index.js under awesome new project, this is everything that's like, this is something that you might see. And you've got to fix each one of these things in order to fix it. So some of them are very easy to understand, and some of them are not. So files is defined but never used. It violates the no unused variables thing. So it's like you created a variable called files, but you never used it. You can probably just delete that. Or I expected indentation of one character, so you had an indentation error. So when you run through this, it'll make sure that you fix everything before you move forward. And more of that can be found down here under eslint.com/docs/rules. And we're going to be doing a challenge with that in just a bit. This is a file that's automatically generated when ESLint comes into your code base, similar to like Sublime's like rules and stuff like that. These are the rules that you're going to basically tell ESLint you want to enforce. So when you come into an error that you don't understand, like no undef, like I don't know what a no undef means, so I'm just going to Google it real quick. It probably just means CLI engine is not defined. You're probably calling something without the variable actually being there. Mocha is like RSpec. It's basically your testing framework. We test, honestly, to make your managers happy and to make sure that the existing features continue to work the way that they're supposed to work when you add new code. If you wrote something and everything is tested, then you add one new thing and everything blows up, you probably don't want to add that one thing. That's the idea behind why you test things. There's different types of tests. The ones that we've been writing are unit tests, the very bottom of the pyramid. Like every single bit of code that you write should have unit tests to go along with it to prove that it works. Your QA team is going to test functional tests, so it's like when I click on this, this particular thing should show up. When I click on this, this particular thing should not happen. So those are things you don't need to worry about. And then finally, you have scenario tests, which impersonate a user and test everything, like across the board. Like I'm going to sign in here, I expect to see this on the page, and click on this, I expect this thing to show up. I'm going to download this particular file, and I expect these things to be inside of the file. Those are scenario tests. These two you don't really need to worry about too much. It's just unit tests that you need to worry about. This is what Mocha looks like. It's pretty similar to RSpec. You'll notice across the board, basically, once you learn RSpec, it's essentially the same thing. It verifies, it's basically like it blah do, but instead of the do, you have the opening curly brace and the closing curly brace for the end. It's very, very similar. Almost done. ESNext and Babel. So browsers update JavaScript engines and stuff on their own schedule. Like you always have those patch numbers that have like a billion digits. Like those are updating the JavaScript engines every single time. What happens if a browser is super old and has super old JavaScript built in? Developers writing in the newest version of JavaScript are not going to be able to, like if I write the most up-to-date code today and someone is operating off of a browser that hasn't been updated in 4 years, like the code that I write might not actually work in those 4 years, the 4-year-old browser. And that's this thing called, that's where Babel comes in. So Babel is a transpiler, not a compiler, it's a transpiler. So what it does is it takes your code and turns it into code that can be read on any browser. It's backwards and forwards compatible. So you never need to worry. Like once you write, if I write old JavaScript code and I'm working on the most recent version of Google Chrome, Babel will take that old JavaScript code and turn it into new JavaScript code. And that's just like something that's built in to create React app that you don't need to ever worry about. It's kind of fun. All right, so the biggest change that we've seen recently is from ES5 to ES6. ES6 came out in 2015, and luckily we've been teaching it this entire time, so it's not going to look very different for you. So here are some of the big things that we have. So the successors to var, you're going to go online, you're going to go to even to W3 schools, and it's going to have var first name equals John, right? That is something like we've always done stuff using var. It's going to change into let and const now. So the big thing is that it's block scoped. If a variable is defined within the block, it's only available inside that block. Let is constant. Let is something that can change. Const is something that cannot change. Let's take a look at what this means right here. Close the door. When you're using upper constants, something that won't change, like before, whenever you do something with constants, you're going to say const right at the beginning, and then do snake case, but in all uppercase for things for those particular constants. So if I say const my fav equals 7, I try to overwrite it, this is going to blow up right here. And when I console log my favorite number is my fav, it's not going to do 20, it's actually going to do 7. Because once you define a constant, you can't overwrite it. So this is block scoping, the thing that we were talking about right over here. When I take a look at this first bit of code, let's just go line by line. We have a function called let var test. I have var x equals 1, and I'm just declaring that over here. If true, which will always evaluate to true, var x equals 2, I'm actually overwriting the original. Like so, if before it wasn't block scoped. Block scope meaning like this is a block, lines 3, 4, 5, and 6, and then this is a whole other block. So I set x equal to 1, and I set x equal to 2 within this tiny block between 3 and 6. When I console log x, I'm going to get 2. When I console log x on the outside of that block, I'm also going to get 2. This is the issue because it wasn't block scope before. I just declare it one time and it's available everywhere within that particular method. When you do things with a let over here, it's a different variable. So I'm going to do let x equal 1 if it's true, which is always going to evaluate to true. Let x equal 2. When I console log x over here, it's going to be a different variable than the original one. This one, before ES6, it was the same exact variable. So when I console log x here, I'm going to get 2. And when I'm outside of that block, this 12 through 15 block, this x equals 1 still remains the same. And it seems like fairly obvious, like why wouldn't anyone just do that to begin with? But this is something that we get for free. The benefits of let and const. Your code is more semantic. We know what's going to change, what's not going to change. Whenever I see a let, I know that's something that can change. Whenever I see a const, I know that's something that won't change. And with block scoping, we know exactly where the variables are going to be used. Another big thing that comes into play with JavaScript is something called arrow functions. Arrow functions, really the fat arrow functions, they provide for shorter code and an automatic binding of this. Let's take a look at an example. So this is an example of ES3 through 5. So let's take a look. We have a function called person. Then we have var that is equal to this. This refers to person. So because remember, variables using var are block scoped. If I want to know the context of this particular person, I have to set var that equals to this, and then that.age equals 0. So the person's age is going to be equal to 0. And then this particular person is going to grow up. I cannot do this.age plus plus. I have to do that.age plus plus to go outside of this particular block. Suffice it to say, this thing sucks. So this is what we have for ES6. Instead of typing var that equals this, and if you work in old code bases, you'll see that all the time. We have a function called person, and this person's age is equal to 0. When I do set interval and I have the fat arrow function, there's an automatic binding of this. So I know what context this is talking about. When I do set interval and I do this.age++, this refers to the person rather than me needing to declare that that equals this because they are block scoped. The next big thing, final big thing before we take a break, is the concept of classes. So classes in JavaScript are very, very similar to classes inside of Ruby, and they're very, very similar to classes inside of Python. Basically, JavaScript was impossible to read for non-JavaScript developers for a long period of time, and with this newest thing, more people can write JavaScript than ever before. So before it looked like this. If I wanted to create a person, I have a function called person, which takes in a name. This.name equals name, this.sayhello equals function, hi, my name is whatever. So if I created a new person called Andy, var Andy equals new person Andy, Andy.sayhello. Like this doesn't particularly look like object-oriented code that we've seen so far. But with ES6, it looks like this. Class person. We don't have do's and ends inside of JavaScript, so this is the opening do, and this is the closing end. Constructor is the same thing as initialize, and say hello is another method over here. It looks very similar to Ruby. It looks a little bit different, but it functionally does the same thing. So the class person, the initializer or the constructor takes in one particular thing. So instead of doing @name equals name, it's this.name equals name. So and then we have the say hello function, which just says hello, my name is this.name, which is what we got over here. Same thing, var Andy equals new person Andy, Andy.sayhello. Hi, my name is Andy. We talked about Babel already. So that's a little bit of background. We'll take a 15-minute break. We'll be back at 10:10, and we'll actually start running through a few of these things together.